Thanks to Calvin Korab for that previous shot, but this is a drone view of the exact same moment. I tried to keep up with this train, but it was going about 40 miles an hour. The drone can only go about 25 miles an hour. Tried to catch in front of it, but did have to flip around, and here we go, we're chasing it. This is in Sutherland, Nebraska. That's about 20 miles or about a half hour before the train went into North Platte, Nebraska. The previous shot was taken from this bridge right here. I followed the train as long as I could until the drone lost its signal. And here is the 4014 Big Boy arriving on the east side of Bailey Yard in North Platte, Nebraska. They do run a caboose on the 4014, but they also run an end-of-train device. You can see extra steam and water escaping these vents at the back of the locomotive. Workers here use a pneumatic grease gun in order to add grease to the bearings. Here's a museum example of the same grease gun. sound you hear is them activating the grease gun. You can see him flipping the switch back and forth and basically applying grease into the bearings. The workers are tethered to the top of the tender because it's so tall, and if they were to fall, it would catch them. Here you can see the large leaf spring suspension of the tender. So this is really interesting. These are called medallions. So each crew member has their own medallion. As soon as they are done with their maintenance work, they hang the medallions here on the engine, and the engine will not depart until all the medallions are present. These workers are adding oil to the locomotive. I think they said they were adding a little more than 2 gallons at this stop in North Platte. The diesel engine is mainly brought along to add load to the steam locomotive. The steam locomotive likes to operate under a heavy load. So they use the dynamic braking of the diesel in order to add load to the steam locomotive. This fuel truck chases the 4014 and refuels it at some of the stops. You can see the brake pads here just behind the main drive wheels. The drive wheels of a steam locomotive are always out of phase from left to right. That enables one side to be giving power while the other side is unable to give power. In this example, on the left side of the locomotive, the drivers are at the 10 o'clock position, just finishing their power stroke. On the right side of the locomotive, the drivers are at the 5 o'clock position, just starting their power stroke. This phasing allows power to always be applied.
That's why I won't lie, right? Well, I don't think you would have been. No. We got to tell stories about he's had trouble with weapons, so we can tell stories like that.
Okay, yeah.
Why would I want to do a good job when I can do this job?
And make just as much money.
Yeah, exactly. Less headache.
Show you. X. We'll get the camera on.
Ed Dickens is in charge of the heritage equipment, including the 4014 Big Boy. Ed personally climbs up and scrolls the Big Boy logo in chalk on the front shield of the locomotive. These large pipes carry the steam from the boiler to the piston. And this is one of the 4 large main drive pistons. Here you can see the throttle linkage. Sand is sometimes used in front of the drive wheels to increase traction. Here you can see some insulation underneath the covers. Since the 4014 was staying for 2 nights, they did drive it up onto a wheel stop. This helps to prevent it from rolling forward. You can also see a museum example of this. And here's the Big Boy making its departure from North Platte. This is the only Challenger locomotive on display in the entire world. In the museum, you can see a huge piston that is from a diesel locomotive, about 11-inch diameter. This drill was hand operated to drill holes in the rail. There were various rail gauges to test the size and dimensions of the rails. Now let's look at operation of the manual brakes on a rail car. As the wheel is turned to apply the brakes, we pull the chain tighter. This chain pulls the rod. That rod pulls another chain. This chain moves the closer part to the right, which pivots the farther part to the left. This pulls this rod. This pulls equally on the right and left brakes, which pulls this bar and pivots the brake shoe onto the wheel. This is a view from inside the Challenger's firebox. Again, we can see sand used for traction just in front of the drive wheels. These are the brake pads seen just behind the drive wheels. This was so sad, but somebody lost their baseball underneath the train and behind the fence. Bailey Yard is absolutely massive and it is bustling with activity. These concrete ties will outlast the wooden ties, and they last approximately 50 years. This is a rare view of the coal hoppers from up above. You can see that there's actually internal bracing to keep them from bowing outwards. There is lots of graffiti on the locomotives and the train cars around Bailey Yard. Apparently the diesel engines start on fire on a pretty regular basis, so you can see some of these have some fire scarring. They also showed us this car carrier full of Tesla cars that started on fire and burned all those cars. Plenty of Union Pacific diesel power throughout Bailey Yard with approximately 300 locomotives. This is called a Jordan spreader. We found this on the way to North Platte. This is used to clear snow off the tracks and sometimes even smooth out the ballast on either side of the track. And here is a museum example of that Jordan spreader. This is a HO scale. Approximately 300 locomotives are in Bailey Yard at any one time. Here's a view of the repair bays next to the diesel shop. The diesel shop has 11 sections of track that can each handle 3 locomotives, so they can handle 33 locomotives at the same time. Here you can see the hump, or the sorting process. So they push these cars up the hill, and then they uncouple the cars and let them come down the hill while slowing their progress and switching them into different tracks. This is how they will sort the cars to build trains for different destinations.
So, I don't know if it's these not getting slowed down enough, or what is the loud bangs I hear every once in a while.
That if sometimes the secondaries don't, they'll still pick up speed even after they went through the secondaries. There's nothing you can do at that point, and you'll hear they'll just hit each other.
Yeah.
So I mean, you can't cover every contingency. Pneumatically. Air pressure.
More.
Yeah, it slows it down to whatever speed it thinks it can still make it to the rail to the next company. Ah, here's a good one. You guys are first tour that got to see that. So.
As the cars come down the hill, they come through what are called retarders. These are large steel plates that put pressure on the wheels and slow the cars down. This is a computerized system, so it knows the speed of the cars, the weight of the cars, and so it applies just enough of a braking force to slow them to the correct speed. You can really see the car slowing down here at the right side of the screen. As we speed up the video, the retarders action is a little more obvious. From this angle, we can see a much better view of the sorting process. Here's a group of 4 cars being sorted together. And again, I've sped up the video for you here. So this is really interesting. A lot of the locomotive traffic around Bailey Yard is using remote controlled locomotives. So when the locomotives have these blinking lights on them, that means they are under remote control. This is a drone shot. We caught this train coming back from North Platte, Nebraska. Thanks so much for watching. Please click subscribe and please like the video to let the algorithm know you appreciated my content.